Today we're going to be making a sensor module for inside my house. Now, this is going to consist of basically three main modules. One of them being this PMS 7003 dust sensor. So we're gonna have that in there. We're gonna have a BME 680 Bosch temperature, humidity, and pressure sensor. And then my last one is gonna be a AS3935 lightning thunderstorm distance sensor. So, yeah, let's get to it. Alright, so today we're going to design a totally new project right now. We're going to do a inside sensor. And we're going to save it as inside sensor. Alright, so the main thing is I want to grab the design for the PMS mod, the PMS 7003. You got a whole bunch of them here. All right, so yeah, no, that's the sensor I kind of want. Saving that one. Our last project, which was ESP tracker. Alright, so I don't really think... Yeah, that could be it. I wish they put a thing on how many... No, these are tabs. These aren't... Nope. Nope, not that one. I'm looking for through holes. Like that. That's fine, I guess. Alright. So the thing is, these need to have... Oh. Do they have, I actually like this one better, because it actually tells you which ones are supposed to be there. So I had to look this up. So pin 1 and 2 are VCC, 3 and 4 are ground. Is that one? Yeah, okay, that's fine, yeah. 3 and 4 are ground. Pin 1 and 2. Okay, so pin 1 and 2 are there. Ground is there. 3, 4 ground. 5 is... Oh. and then 10 is set. No, they had this reversed. Wait, do they have it reversed? That's kind of why I wish I had. Bottom. Is there a way we can rotate this? Oh no, cancel that. Don't save. Don't save that. Control save. We're gonna throw this into convert to PCB. No, keep going. Oh, it doesn't have it. Shit, it doesn't have the lines. Motherfucker. I thought I put that one in. Save. Don't save. Convert to PCB. No, keep going. Apply. Because I'm looking at this from the wrong way. And it's gonna go bottom layer. So I got this in the, I guess the same form that that has. Alright, so pin 1 is VCC, pin 2 is VCC, pin 10 is set. Yes. Pin 9 is TX. Yep. RX. Alright, so, okay. Wait, wait. 8 is nothing. 7 is RX. 6 is nothing. 5 is reset. And ground. Okay, so this is the one we're going to use. This is the one we're going to use. Alright. This is the one we're definitely going to use. Alright. Alright, now I gotta decide on what chip to use. Kill that. Diagram for Wemos D1. Because this is going to be the first time I'm going to be using this. I just realized this is the first time I'm going to be using 5-volt ground D4. That's for Tesmoda. In ESPHome. Alright, so the thing is, I want to have this so it's working with ESPHome. Alright, so actually I gotta do Wemos D1 pinout. One and three. Okay, it doesn't really tell me much. ESPHome. There we go. Which one did I want to do for this? Which one? I think it was this one. Nope. We're gonna go for that one. There we go. Nope. All right, so what's GPIO 23? What's in ESP32? 32 pins. There we go. ESP32. 23. Where's 23? Oh, it was 23? Alright. So it looks like maybe I can use any pin. Alright, so that's fine. So we're just gonna go with... We're gonna try and go for the 8266. Because those are cheaper, more affordable, and I guess more reliable. They're not more reliable. They are what they are. Let's grab it from here, because I know these work. Ah. All right. We're also going to need sensors for You know what? Do I want to make this a display? Or do I want to just have this, like, there? No, you know what? Let's make it a display model. I should have another ESP32 with a screen. And then parts list, nope. Our next part is going to be, what is it now? eBay, check up on, yeah, BME. Okay, so BME 680. And it looks like trying to find it here. Okay, it's got like a little notch on the top. Alright, so not that one. Nope. That one. That one. I think. VCC, ground, SCLA, SDA. This one might need to be nope. Alright, that one done. Delete that one. Alright. Alright, so yeah, I'm having a bunch of issues with OBS Studio not connecting tonight. What's going on here? My download's pretty good. Yeah, my download's pretty good. Like, what's going on with upload? Oh, now that I do the test, we're rocking. This is some kind of bullshit by Comcast. This my internet service provider, I think, is just kind of like messing with me at this point. Cause like, I didn't have that open, and now I'm like fully up and running. I really hate this. I really hate this. Anyways. Alright. So this one's that one. Okay, and then I need my last sensor, which is my lightning sensor. So this sensor I got because honestly, if I'm trying, I don't listen to the news, I don't do nothing like that. If this sensor's to be believed, what it does, it can detect lightning strikes. So for a couple kilometers or something, I forget what the exact does it say in the description? Between 14 and 40 kilometers. So Yeah, so I should be able to say see if something's coming. No? That looks about right. Alright, so we're gonna have those. You know what, I'm gonna say lightning detector. See if that comes up with the library. Nope, this is all sound detector. Nope. Lightning. Oh, these are lightning. Oh, is this like Apple's lightning? Oh, like lightning detector. Light detector. Alright, alright. Apple, you can have lightning, I guess. Alright. Because I'm kind of like 50-50 on this. Should I make it a display? Or should I have it do what it was always... or just have it off, small off to the side? I think the word screw it come to mind, and might as well just do it. Because I really want two designs for this. Because I want to have this also outside. Not with the freakishly large air quality sensor, but with these two sensors there. Yeah. We're also gonna add a, I think I'm gonna add, do I want to do that? Orders, IR, an IR sensor, an AM312, because if it detects something, it'll turn on. It'll detect, oh. User contributed. The breakout. Nope. Copy. Nope. You know what? You put the time and work in, so I'm gonna use you. Alright. So, this is what I'm gonna have. Is there anything else I want to throw in there? Do I want to throw a motion sensor in there? Maybe not. Oh, that's right. I wanted to do another... Okay, this was going to do everything. This wasn't just going to do that. It's also going to have the breakout module on it, too. So, it's also going to have my inside, the CCS811 to determine if what levels of volatile gases are inside. I don't know. I forget what it is. Toxic gases. So toxic gases, pressure, temperature, humidity, and which is this one? Oh, lightning. I also might want to throw on another BME. Actually, wait a second. Do I have one of these? Yeah, I'm going to use another. I'm going to use the same chip as I did before with the other wall one. And just have a temperature pressure kind of thing going there. So just in case like one of these kind of messes up. So we're gonna just... Alright, these are all the things I want. This one's probably gonna go over here. Copy what that says. We're gonna... pins. Images. Yeah, we're gonna use this one. We're probably not gonna use that one. Open image in new tab. Here we go. Alright. Alright, so let's just do the thing that... Get those. Align them all there. Let's just grab everybody's VCC and ground right now. Next is SCL. 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 SDA. 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 Okay. So all those lines are good. All right, next. VCC goes to 3.3. Let's connect some of these grounds. All right, save that. All right. Next, SCL. SCL is gonna be pin 22. No, this is not the right board. That's the board. Open image in a new tab. Ground 21, 22. Right? Oh, why am I reinventing the wheel? 21 and 22, yeah. '21 is SDA. SCL is 22. There we go. Now those are all hooked up. Now I gotta figure out, is there anything special I gotta do for this one? No, I don't think so. Cool. That means you VCC 3.3 signal. I'm just gonna use 17 and then ground. Throw all the grounds together because I don't really care for that. So next is going to be, actually, if I'm going to do this, I'm going to do it right. There we go. Next, wire the 5.5 up to 5.5. Ground to ground. Then ground. Oh. To ground. All right, now. Oh no. ESPHome IO. PMS 7003. Oh, I did two S's. Alright, so what do I need? I need the baud rate and just the pin. Alright, so not using that one. Nope. There we go. Where's RX and TX? Oh, son of a bitch. It doesn't tell you. This might be the reason this thing kind of falls apart. And I have to do nope, that one. Oh, no, I don't want that GitHub. Oh. Open image, a new tab. Nope. So this thing just needs an X. Okay, so... Actually, you need to set the baud rate at... As communication with the ISIN UART, you will need to have an UART bus in your configuration. Yeah, does this not have a UART? I guess it doesn't. Because right now I'm trying to figure out where the UART is. The RX and the TX functions. I might just have to go. Yeah, it says interface. It has UART, but it doesn't show which pins it is. Ah. Alright. Why is the more... So that's what I never got. This one's the 16 megabit. That's 4 megabit. The 4 megabit should be cheaper than the 4. It's $1 more for... It's $1 less for more memory. I don't get that. It confuses me. Anywho. We're just gonna take a lucky guess. Probably. Alright, so... So where it gets all confusing, and I might have to just... ESP32 pins. I'll have to guesstimate, I guess. Unless... Nope. Okay, which ones are UART? Okay, 1 and 3. 1 and 3 are not on here at this time. 16 and 17. 17's there, but no 16. Wow, whoever designed this was a complete and utter idiot. Like, you want to keep your pins for that. Oh. I'm gonna have to figure out something else. Well, I mean, there's nothing else I can do about that. Because if it doesn't have the correct sensor, I can't keep it going. Now I gotta figure out which chip I want to use. Because that just like really screwed me up. We'll just use a normal ESP32 chip. That's fun, I guess. Really just... I don't know, it really confuses me why that happens. Just use the standard ESP32 chip. Do I want to just use a standard? For this project, sure, why not? Actually, if I'm not going to have a display on it, what's the point? Why don't I just go with something? No, because I do want to do a few more tests on some other boards that I want to have, but not right now. So we're just going to grab the standard ESP32 kit. There's going to be no display, so I don't need to turn it on at any point. We're not going to be using that screen. We're going to be using... Where's the ESP32 that I... Oh, I just had one for home tracking one, right? Yeah. Copy that one. Just throw it in here. There we go. Get rid of that one. Alright, and because... Do I want to make this as small as I can? Yeah, you know what? Why not? Delete that. That. And that. Okay. So we're all good so far. Delete those. Delete that. Okay. So let's first hook up what we had. VCC. And we're going to do... the ground right there. Alright, so we got ground there. Okay, that's done. Next is going to be... Oh, come on. You were supposed to... I hate you, Windows 10. You keep with me. $22 and $21. $22 is SCL. What are you doing? Screen, stop being a bitch. This is when this program starts whacking out. SCL. Alright, then SDA is going to be 21. Yep, okay. Alright, that's good. We're all done there. That's there. And we're going to ground it there. Alright. Next, 1617. RX. RX goes to TX, which is 17. And then 16 goes to TX. There we go. Just making sure 10. Oh, yep. Okay. That's fine. All right. RX TX there. And alright, so we don't need anything else, right? We just need the baud rate and the RX pin. I don't need the TX pin, but I'm pretty sure at some point it's going to come into effect. All right. Save this so far. AS 3935. Franklin lightning sensor. All right. SI select interface, ground is SPI, VDD for squared C. Okay, so this is the thing I gotta figure out. Hey, Piggy Bacon 638, how you doing? Thank you for joining. All right, so I gotta figure out. All right. Okay, so the SI. So we're doing I squared C on this thing. So the SI has to go and be 3.3 volts. All right. Voltage regulator enabled. I don't think I have. Wait, do I have that on my chip? Or is mine just more of a... See, that's like the really weird thing about my chip. VCC ground. Mine's kind of like the complete inverse of whatever this is. Oh, hi. Is there supposed to be sound? Yes. Yes, you're actually supposed to be hearing things. Did my stream like mess up? Yeah. you're supposed to be hearing me. I don't know if... Oh, man, was I just recording nothing for the past... yeah. Let me... Okay, so that's really concerning to me, so I gotta go into my recordings. Okay, oh, no, 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 no. There. Why does it do this? I hate Windows 10. Recordings. My recent recording. Oh. Anyways, yeah. Today we're gonna be so we're doing I squared C on this thing. So the SI has to go. Oh, yeah, okay, so yeah. No, it's not that complex. So right now I'm just creating a PCB for a bunch of sensors for like your house. One's going to be for particles in the air to determine whether or not you kind of want to oh, did I do that wrong? I did that wrong. Going back and explaining things actually helps me out sometimes. But one of these, this is going to be for particles in the air. This one is for, this BME is going to be for temperature, humidity, and pressure. This one is for volatile organic chemicals. This one is for a lightning sensor if there's lightning outside your house or something. And oh, so yeah, as much as I know how to do calculating in standard. Oh, okay, so everything is going to be, this makes it real nice and easy. It's going to be run by ESPHome. So ESPHome, just basically it's drag and drop kind of thing. Yeah, I know it's not like I want to code everything myself, but then I realized that why would I not want to use something that's already done? This website is pretty great. You just load ESPHome onto your Home Assistant. And again, Home Assistant, I'm going to be using that for myself. And so I can literally throw everything, all the sensor data goes to Home Assistant from ESPHome. And it's kind of easy to do. I can show you later when I order the board, and I'm gonna come back to it. All right. Warframe play. Okay. Okay. So what are you saying? Design an integrated circuit. Okay. So, I just went over it, so I'll just quickly go over it again. So this design, I'm making a internal sensor for my when I get a tiny home, I'm gonna be moving in there, and I gotta what's the word I'm looking for? I gotta know everything that's going on in there. I'd like to know. So I'm gonna have different sensors determining what the air quality is in my place. So again, particle sensor, temperature, humidity, and what's the other one? Pressure sensor. This is for volatile chemicals like alcohol, or I forget what the other ones are. A lightning detector, so like if a storm's coming, I can sense it and be like, hey, I gotta close all the windows, or have my house do that instead of, and automate my house to do that instead of me doing it. I can be like, yeah, it's coming, close the windows. And so This is all going to be... I'm designing the circuit right now for it. And I have to have all these things. I got to go through each sensor and connect it up. We're going to be using ESP32 for this project, which is, I guess, like standard now. Yeah, I'm basically making my smart home in some ways. There's going to be many different boards that I'm going to be making. I've already made a few, like light switches and stuff like that, but I'm not trying to order anything that I don't know what it does. So like, you know, you order from like LifeX, the bulb turns on, but you don't know how it works internally between their servers and when it gets to your place. Or, let's say, She Who Must Not Be Named. So you don't know what happens between here and when, you know, you say, I'm going to regret saying it, Alexa or Google or something like that. She heard me, but she didn't respond. That's great. So, oh, crap. No. Crap, my internet's... It's been going on and off. I really hate this. Okay, we're back. Okay, we're back. Okay, we're back. So yeah. Normally it isn't this bad, my internet. For some reason tonight, even though it's like almost midnight where I'm at, it's still like complete shit. But yeah, I'm sorry about that, guys. There's nothing I can honestly do about it. Okay, so where was I in this? So what was I saying? I'm all screwed up. So this one, again, I'm collecting data for myself. Eventually, I'm going to make this also an outside one. So, okay, still understand nothing. Well, what I'm trying to do right now is I'm making a diagram, or a breadboard, or PCB board. Those green circuit boards. And I want to gather data right now. My whole point of this project is to gather the data inside the house. So I can tell if the air inside the house is good or not. So, in a way, yes. It'll tell... The whole point of this is to tell me whether or not the air is clean or not. And if I should open a window, or turn on a fan, or... yeah. Yeah. So, yeah, basically, what I'm creating is a bunch of sensors so I can gather data and then figure out what to do with it. That's... Figuring out what to do with it is going to be another PCB design. For, I guess, opening windows or turning on a fan or something like that. That's going to be a separate project. But right now I'm just gathering the data in so I have it. So if I manually want to do other things with it, I can open a window or something manually instead of that. No patent registered. Again, a lot of these things that I'm doing, I think if you want to do it, you can have it as open source. A lot of this thing's out there already, and I'm just borrowing code from basically these guys, the ESPHome community. So this isn't really going to be covered under, I guess, any type of lawful claim to myself. I'm just putting what I know out there, I guess, and doing these projects online so it inspires people to do more projects like this. There's nothing really there's nothing really I want to keep from this other than just doing it. I'm gonna do it anyways, might as well stream it, and that's kind of where I'm at right now. All right, so okay, so right now we're gonna be finishing up connecting the sensors. Yeah, I hope it works too. Otherwise this is gonna really suck. I can't do it right now. Oh. I hate my house internet. IRQ. It's pin 12. So we're gonna move 13. Alright, we're gonna do that there. I honestly don't know if we need the rest of the other pins. I don't think we do for this one. But this honestly it still concerns me about how this all kind of works out. Did I grab the right pin? Yeah, I grabbed the right one. That's fine, I guess. Oh, they have the IO. Okay, so inside. I need to replace the transmitter inside an integrated circuit for an RC quadcopter. Wow. Okay, so like that's really oof. So you need to figure out what's wrong with it. I don't have a microscope. Some of these, okay, so some of these projects like that, like for that one, you can look at the schematic and try and figure out, yeah, it depends on your level of comfort for this stuff. If you don't feel like buying a multimeter and just trying to trace it out and see what's wrong, yeah. Man. All right. Yeah. So MOSFET. SQ, SDA. so... Okay, so IO1, that's fine, that's fine, that's fine. SPI data bus, nope, that's fine, we're not gonna connect that. Chip select, active low. Oh, chip select, okay, so that's for the other way of running it. So you can run this chip in two different ways. You can run it in I2C or SPI. SPI is faster, but I don't care about being fast. Yeah, time is money. Yeah, sometimes when you for electronics, it's easier just to buy things than to fix it. Honestly, for stuff that's made in a corporation, again, this is again why I want to actually create some of my own stuff like this in as a circuit. Is just so I can have the know-how how it works, and so if it breaks, I can just easily say, hey, just replace that chip with that, or that board with that, and just have it work. Alright. So, I think even though there's two things that are, two holes that aren't complete on this one, or, yeah. That's enough. Yeah, if you want to get into projects, buying a multimeter is good. This is live that doesn't come back. This is live that doesn't. Cause they. Yep, multimeters. You can do a lot with it. Make sure it's also AC and DC when you buy it. Some of the cheaper ones are just DC. Or they're like really shit AC. Don't try and like cheap out on it. You can kind of cheap out on them, but all right. So okay. So the chip that CCS811 is for O2 CO2 value, and also has a total volatile organic compound sensor on there. This one I just need which pins? Just SDA and SCO. Address. No, I don't need a different address. I don't need to reset it. I don't need initialization because it's not going to be woken up. And that's fine. Alright, so this one is done too. BME 680. I gave it F5. What? Oh, it returned. Oh, okay, you're back. Oh, this one also has a gas sensor on there. Huh. That's cool. Temperature, pressure, humidity, and gas resistance. Huh. And what does this need? The I2C bus needs to be set up in your configuration for it to work. Yeah, I kind of figured that. Oversampling. Oh. Alright, so this one just runs off of, tip select, SD. No, this one, I think this one needs to be... I hate when things don't run off of one or another. I have to look this up now. I wish there was more. Let's go for Adafruit really quick. Alright. Oh, it's basically a circuit. Have you integrated circuits? Not easily works. Have you finished college? Yes, I have finished college. I've actually been in the working world for a couple years now. Nothing like this, to be honest. Oh, no, not that. Nothing in my field, really. Right now, I'm kind of tech support for a library, if you want to call it that. But right now, I don't... so it's basically short, but it's big and it's tiny. Alright, so... as for the circuit, integrated circuits, yeah. Oh. Ugh. I'm probably gonna end streaming after I finish this really quick. So how do I do this now? Descriptions, Stingly QT. Yeah, detailed stuff. Show me how to use you. How do you, okay, so I kind of just let other people do the work for me, because start an SPI transaction. It's input to the chip. Ah, okay. So I don't think I need anything. I don't think I need anything for I2C connections. Well, okay, so if I'm using I2C, I don't need to do any of these other things. So for right now, our boards are good. Our boards are good. We're ready to go. Everything's schematic-wise is done. Let me know in chat if you came back. It looks like... Oh, you already said we'll close. It returned. Okay, yep. Yep. We're back. This is gonna be really shitty. I really hate when this thing doesn't work right. I'm sorry, you guys, for putting up with it, but thank you for putting up with it. We're gonna change the title, inside air sensor. All right. It shouldn't be that bad. Normally, I stream pretty well and frequently. It's just where I'm at right now. I guess I haven't been streaming for a while. And so Comcast kind of likes to fuck with its the people that pay for it, and I guess they don't budget the bandwidth for it. So I guess that could be a thing. That shouldn't be a thing, but it is. Alright. So we're going to convert this this diagram into a PCB format. No, we're not going to check nets. I forgot about that. No, keep going. Apply. Okay, so now we got the diagram done. We're just going to basically throw all our parts up and onto this board right here. We're going to arrange them the way we like and try and get it as small as we can, because again, this thing's probably, I don't want this thing to, I guess, sit out places where it's not. Oh, Piggy left. Oh, sorry about that. Yeah, no, I wish more people would stay, but I think it's because, again, the internet's like really bad and it just drops for like no reason. All right, so we're gonna try and arrange stuff. So it'll work. I'm not sure if I want everything on just one side or try and make it as small as possible, so I can just kind of like have man. All right, I think we're just gonna put that up there. That's our temperature and humidity sensor. Let's put our gas sensors down here. And just right there. I think that's it really for this. And all I gotta do is connect it. Can this project give any financial return? No, this project isn't gonna be financially... I'm not gonna gain anything financially from this. Unless you call Twitch or something else. This, I don't know. I might post things on GitHub, or when I start getting more of these together, I'm gonna probably make a GitHub, throw them all on there, and have it open source for everyone to use. I don't care about monetary value for this kind of thing. This is kind of like, I want to say, my project that I don't want to, I don't care enough to put this all together. I mean, I could probably do it. I'd probably have to compete with a bunch of other companies, but and I'd probably have to design it a bit more. It'll be a bit more detailed, because a lot of these things are just modules that I drop in that have all the components on it. I'd have to literally look at the components, order each one, and there's like at least 10 per 1, 2, 3, 4, 5, 6, 7, 8. There's like 8 on each one, and they kind of add up after a while. And soldering everything by hand kind of like defeats the purpose of it trying to be a real easy project, and kind of like, I don't know what I'm supposed to say for it, but like, I don't want my work to be work. They're all right. They kind of, like that, I guess. I haven't really taken it to a point where I think they'd be proud with me, but, I guess once they see everything all done and done and stuff, I can do that. I guess it wouldn't be that bad. Alright, so on this module, there's kind of a fan piece near the bottom for an intake and an outtake. And I'm trying to put my sensors kind of close to that. So that way the air gets pulled in and it also passes over the sensor. But I also want it to not be so close that it blocks the fan distance. Or the fan, yeah, the fan intake. These other ones up here, I don't mind so much. This temperature sensor is just a backup one for everything else that's going on. We're just going to try and bring everything a little bit closer together. I have room for one more sensor or something here. That's what I need to do. Okay, so we're going to go back in to designing everything. And we're going to grab some components from another project that I just finished up. The tracking one. We're going to grab... We're going to grab these. The LED and a resistor. And we're going to throw them in here. Because I'm thinking... I found this layout confusing. Oh. So, alright, so... Okay, so are you confused about this one? The PCB? Or the schematic that I'm working on right now? I know I kind of get like some, I don't know. If you want to describe it as like, I get really distracted by stuff. And my thoughts kind of like leave my lips before, or no, they leave, I like do things before I like really know what I'm doing. And I'm kind of like on autopilot like half the time. So I gotta wire all these LEDs up. Alright. So what I'm doing here for these LEDs is, when the air is good, I'm gonna have a red LED turn on. Or when it's bad, I'm gonna turn the red one on. When it's green, I'm gonna have a green LED when it's good. And I should have a third one, shouldn't I? Just for like... And a third one for yellow, I guess. Disconnecting. I really hate Comcast. Alright. So we're going to save this. We're going to go PCB. Okay, so we're going to update this. The PCB. So I've added 3 LEDs. One's going to be red, one's going to be yellow, one's going to be green. And they're going to determine after all these things come into play, they're going to determine what's kind of good, what's kind of bad, and what's kind of in between, where it's going bad, but we're not there yet. So we're going to save this, and then we're going to update the PCB into the black, no, keep going. That's fine. Oh, wait, no, cancel. What is this? This has never happened before. Okay. So I gotta... I gotta update. Okay, so design, update, import changes. No, keep going. Apply changes. Okay, so I imported the LEDs now. You understand economics, elastic and inelastic curve. Not really. I really don't know that much about economics. Although I know that because of what's happening, we're probably going to get screwed for the next couple of years. As the world tries to figure out what the heck's going on with itself, as God forbid we start World War III. Alright. Oh, wait, all these need to be rotated so they can fit, kind of. Alright. Alright, so right now I'm just placing the components where they should be on the board. The purple box is kind of where is the outline of the PCB, the board that I'm gonna order from. And alright, yeah. No, we're pretty... Actually, we're almost done right now. Alright. Oh, shoot. There's one last thing I needed to do. Yeah, it's just organizing everything, all the components on the board right now. That's what the black thing is. I forgot one major thing though. And that's gonna... This is why it takes like engineers kind of a while to get their designs in order. Because they want to just get it all down first on paper, and I don't like to do that. And then build it so they don't forget anything. I just do the opposite. Again, we're going to go back to a previous thing. We're going to steal a component. A bunch of components. From a previous design. We're going to throw it into our current design right here. Oh, did it not work? I can't copy and paste. Copy and paste. Do you have... really done. Copy that. There we go. Okay, so we need a power in. We need power to get the thing going. And I'm also going to have a 5-volt regulator. So that way, have you ever thought about doing something to be remembered something important? Nah, not really. I haven't really thought about that too much. I just do what I want to do in life, and that's kind of where I'm at. And I honestly think that that's kind of like what everyone should do, to be honest. Like, if you do what you want to do, if you want to be remembered, that's like, I don't think that's a good way to live, because then you try and always up yourself. Okay, I gotta put the output, the 5 volts out is gonna go into our board, and then our ground is also gonna go to our board. And again, if I already have 5 volts, I can always bypass it by putting a metal piece of metal over and just bypass this instead of putting that component in. But anyways, oh, message arrived there. Have you ever thought about doing something? But, yeah, no. Message arrived there. Yeah. No, I'm sorry if it takes like a minute for me to respond to chat, because I am actually trying to look at this, and then I gotta turn my head, look at chat, and then I gotta turn back and do, and then do this. We're gonna update the PCB. All right, so power. Power is always good to have. I don't want it near that. Actually, I'm gonna put this out further, because that's the that's gonna be sensitive to, I guess, electric components. Notification ringtone. I don't know how to put those up yet. I'm using OBS. I don't know if there's a link for that. I would love there to be one. I just don't know where it would go. I don't know how it would... where it is. If you could forward me a link to that, that would be great. Because I really do want to interact with chat more. And half the time, I'm not looking at a screen. If you know where that is, like, I would be so grateful. Because I haven't really come across anything that doesn't take like a gajillion steps to do. Like, that's the thing. Like, I've tried a few of them, and they just like kind of fail on me after a while because OBS updates, or they don't support it anymore, or something like that. And I've just been like really bad. Oh, 10 words you say, I understand 2 or 3. Oh, sorry about that. So, what was I going for? Anywho, for notification ringtones, I haven't really been great with that kind of software. I haven't really found anything that I like yet. Alright. Oh, yeah, no. So, what I do after okay, so let me just really quickly auto route everything. Design rule, design change. So, never mind that, actually. So, what I do is I can go to fabrication, PCB fabrication. I'm just going to ignore everything for right now. And then I can order it, one-click order. And I can literally order these things. And yeah, I'm gonna build these things in real life. I have all the components at home. Yeah. So this is like for small scale. This is small scale PCB ordering. I could actually order. Wow. I didn't know they actually had that. Yeah, no, I can order 8,000 of them if I wanted to. I didn't know they could do that. Last time they had it like up to maybe like, I don't know, it was like 200 or something last time I checked. These guys have really stepped up their game. So I order them from JLCPCB. And they're just like really cool. Due to the server. Oh, you stupid thing. So, oh, wow. That was fast. But yeah, these JLCPCB, really does do some good work. I'm not gonna badmouth them. They're pretty great for what I do. What I use them for. I might get some better software, to be honest. I'll still probably order from them, but I'll use different software. This is their in-house kind of like stuff right now that I'm using. And again, the smaller you make the PCBs, the more inexpensive they are, but yeah, cool. There are times the times of these lives these afternoon. So right now I'm what is it now? It's almost 12:30 at night or in the morning, whatever you want to call it. 00:26 if you want to be military time, I guess. I don't know. What was I looking for? Oh, trace with calculator. So for when you order things, in order for the power to go through, if you know about amperage and stuff, if you don't have the right thickness, your PCB could potentially fry itself. So I need to have some things, like the power lines are going to draw like 2 amps. So I got to beef them up. So generally, this is going to be 2. Or I delete that and just do my own. Oh, nope. You're from Brazil. Oh, I think we're in the same time zone. I'm in the New York time zone, so like, I think we're pretty much kind of the same on that. East Coast. Yeah, 1 or 2. Okay, yeah, 1 or 2 hours difference, but not too much. Alright. That should be alright for now. You know what? Let's delete that. What'll be the next steps after it's done? So again, after it's done, I'm gonna send it away for it making it, and then in about 2 weeks, it takes, what is it, 4 to 7 days for them to make it, and then another week for it to come here. And again, I'm going to be rushing a lot of these through, again, because of the global problem we're having. If I say war, Russia will say I'm bad, but yeah. So I order the parts, it comes in, I build it on stream, and then another day I program it. So these guys are from China, which yeah, JLCPCB is located in China, but China has been like hands off and kind of supporting Russia. So the chances of them getting like sanctions against them are kind of gonna it's horrible, but it's probably gonna affect all China too, if China doesn't like stay out of it. They are trying to right now, but I don't know if it's actually going to take or whatever. Next time live. That honestly depends. It could be tomorrow. I also try and like stream games and stuff. Oh, man. Yeah, I also stream games, so tomorrow might be Pokemon Arceus. I kind of like that game. I like how Pokemon's been like evolving in its I guess in its quest to do more and try and get better people, or try and do more artistic designs. I want to call that be more than just fight, battle, and stuff like that. I like the fact that they're open world. Do you have many friends out there? I have a few. It's just, I don't know. I like being kind of inside. I don't know. Yeah, no, it's alright. It's just, I have, it's also the thing that I kind of don't trust a lot of people, but at the same time I'm trying to open up more and just be a better person, I guess. I don't know. It went down. Of course it did. Of course it did when I'm trying to open up and shit. I have a few... Of course it's gotta go down when I'm... No! Okay, I should really have something in... I should really have something for that. Whenever it goes down, it should say something in chat, and when something doesn't work out, it should try and... But when it's back, it should... I gotta do that. Yeah, okay. That's fine right there. That's fine right there. All those are lined up. All those are connected. So we just see, make sure all the modules have 3.3 volts going to them. So, yep, 1, 2, 3, 4. V in. No, that's ground. Everything has ground too. 1, 2, 3, 4. Okay. And V in. Oh, that needs to be a bit bigger. So, yeah, so, I have a review exercise to do. Oh. Economics and statistics. Yeah, no, you keep it up. What are you trying to be in life? What are you going for? Are you going for accounting or something? You going for business or? Because, I mean, statistics is kind of hard. Economics and statistics are kind of hard. Oh, your course has nothing to do with that. Huh. Why would they assign you that homework then, or whatever? Or that review exercise? That seems kind of a waste. Executive secretary, okay. I guess you would need to do that for that, I guess. I guess you would have to handle some kind of finances in some point. Fabrication. Okay, yeah. Check DRC. Oh, 2 errors. Oh. Ah, that's the last problem I have right here. Here there are a lot of prepared people and few jobs. Yeah. Hopefully with COVID finishing itself up and everyone getting the vaccine, maybe there are hopefully more jobs in the future that are going to come everywhere in the world. So I hope that I hope you get it. I hope you. All right. Executive secretary. Yeah. Man. Just the world right now, in the way it is, it's kind of, eh. Alright, so let's see if I cleared all the errors. So, in this program, there's a DRC error. So that just basically makes sure that nothing's incorrectly placed when after you wire it up and make all your adjustments. And make sure that everything should be good. And since I have no errors, I literally can just order it right now if I wanted to. And I won't do that right now because, again, well, not again, but I won't do that because credit card information is not something I want to give out on the internet. It's one of those things. And I have a few more projects I kind of want to do before I send out a massive order for them, and then because shipping, $20 a pop. That's what it is. No, you're fine. If I get in the way, let me know. No, it's fine. To be fair, I think I'm about ready to get off right now. It's been 2 hours on this project, and then I had another hour on the other project that I was doing before making a tracking device for my tiny home that I'm going to have and build myself. So, Cavaliero Semi-Nom. Is there anything else you want to say before I get off? Is there anything else? Because, again, I am going to get off now. Just type that in chat, because I know you've been very, very cool with me. Nameless Night. Yep. I'm sorry. So, yeah, I know, sad face, sad crying face, but I'm almost I'm over 3 hours in streaming, and so all this is done. We're going to again send it out offline. I'm gonna order everything offline, and then we're gonna just I guess meet next time. I don't know when. It's either gonna be tomorrow, about a little bit earlier, actually maybe a lot earlier, if not maybe Monday in the afternoon, Eastern Central Time, or Eastern Time. Oof. So, oh wait, do I have an Instagram? I don't know if I did that. I have a Twitter. Do I have an Instagram? No, that's Facebook. Or if YouTube. Oh, Steam. I have Steam. And yep, Twitch right there. All right. So, anyways, yeah, I gotta get better tracking for my model, anyways. All right. Anyways, have a wonderful afternoon, evening, night, when wherever you are in the world, and I guess I'll catch you guys next time. I also re-upload everything to my YouTube channel, so I'll see you there. Bye.